Hello viewers, in this session we take on water scarcity. Now, water scarcity is the lack of sufficient freshwater resources to meet water demand. In 2019, water scarcity was listed by the World Economic Forum as one of the largest global risks in terms of impact over the next decade. It is manifested by partial or zero satisfaction of demand, economic competition for quantity and quality of water, disputes between users, irreversible depletion of groundwater, and negative impacts on the environment. 4 billion people live under conditions of severe water scarcity for 1 month over the year, while 500 million live under perpetual water scarcity all year round. The essence of global water scarcity is the geographic and temporal mismatch between fresh water demand and availability. Increasing populations, rising standards of living, changing patterns of consumption, and the dramatic increases in irrigation agriculture are the main driving forces for the rising global demand for water. Also, climate change, increased pollution, and wasteful use of water can lead to insufficient supply. All causes of water scarcity are related to human interference with the water cycle. Water scarcity varies over time as a result of the natural hydrological cycle. However, it varies even more as a function of the economic policy, planning, and management approaches. Scarcity can be expected to intensify with many forms of economic development. However, if correctly identified, many of its causes can be prevented, avoided, or mitigated. According to the International Resource Panel of the UN, governments have tended to invest mostly in large projects such as dams, aqueducts, canals, and reservoirs, which are really not so environmentally friendly, neither are they economically viable. According to the scientific panel, the most cost-effective way of decoupling water use from economic growth is for governments to develop complete, holistic water management plans that take into account the complete water cycle from source to distribution, economic use, and back to the environment. In any case, with all of this, a total of 600 million people worldwide lack access to safe drinking water. In this regard, Biochar, with its excellent capacity to remove many contaminants from aqueous solutions, constitutes an untapped technology for drinking water treatment. Biochar water treatment has several potential merits compared to the existing low-cost methods such as sand filtration, boiling, solar disinfection, and chlorination. Biochar is a low-cost renewable adsorbent made from readily available biomaterials and skills, making it appropriate for low-income communities. Furthermore, existing methods predominantly remove pathogens, but Biochar removes chemical, biological, and physical contaminants. Also, biochar maintains the organoleptic properties of water, while the existing methods generate carcinogenic byproducts. In addition, as discussed in other sessions, spent biochar can then be applied to land as a soil enhancement, thereby improving crop yields. Therefore, introducing biochar into the water sanitation systems transforms linear material flows into looped material cycles. Lack of design information on biochar water treatment and on environmental and public health risks constrain the use of biochar for this purpose. Viewers, biochar will keep cropping up in many of our sessions. This is because biochar is a potential solution to many environmental problems.